Chris Newland and Julio Sainz with Team NotSoLost, working with Stuck on an Island.
So now we're going to review the 7 steps of the functional development process. So the 7 steps are: clearly define the problem. Second, create test matrix. Third, outline the solution or algorithm. Fourth, test the algorithm. Fifth, translate algorithm into Java. Sixth, run all of your test cases. And seventh, deploy the code. So step 1, clearly define the problem. We needed to find a way to calculate the energy used over the distance traveled. This would ensure that the player had enough energy to make the trip. In step 2, we created a test matrix using Excel. We left it blank since we had not ran our pseudocode yet. On step 3, we created our pseudocode using a Word document, the if statements, to return errors if they weren't true. And then we also wrote the pseudocode to execute the algorithm. On step 4, test the algorithm. We added values to test the different cases. For example, case number 1 tested the valid results for new energy level, and cases 2 through 5 did invalid, and last, case 6 through 9 did the boundary. The boundary calculated the minimum and maximum values that we could enter without returning an error. Step 5, translate algorithm into Java. So we took our pseudocode that we wrote in a Word document and we translated that into Java code, as you can see on the right-hand side. Step 6, a test method to run all of our test cases. On the left-hand side, you can see the Java code that we created to run these test cases. Once we run the test cases, on the right-hand side, you see the results that were returned by the test method. The last step, step 7, deploy the code. After we created our code, we committed that code to a local repository. Once committed from GitHub to make sure that we had made by others. And lastly, we pushed the code back up to GitHub to make sure that our code in GitHub was up to date.
Java selection statements. The first one we're going to cover is the if statement, which is probably the most basic of all the control statements. It tells your program to execute a certain section of code only if a particular test evaluates to be true. For example, the pool class could only allow the diver to safely dive if the pool is sufficiently filled with water. Next. Here's an example of if statement contained in the calc pack weight function, and when the rings true, then it executes the formula and calculates the new pack weight, which it returns to the actor. Next.
And the next selection statement is the else if statement. And in an else if the condition of the if statement is found to be true, the code of the if statement will execute. When the condition is not met for any reason, the else code will be executed. And then either way, if it's the if or the else if code, they will return a corresponding result. Here we see, in this example, there are multiple if statements. If any of their conditions are met, they will execute and return -1, pushing an error. If none of them are triggered, the else code will be executed, performing the equation and returning its value.
The last selection statement is the switch statement. This statement can be used when creating a menu. On the upper left-hand corner is the text that would be displayed so that the user can make a selection of the menu. There are 4 selections in this example. If the user selects R for return to game menu, it will execute the display health menu view method shown right below it. When the user enters R, it will return the view back to the previous menu. If it's something other than R, it will execute the do action method on the right-hand side of the screen, and then it will compare what the user selected, and it will run through the switch selection statement. So in the switch selection statement, you have case statements, and what this does, it'll grab the user selection and it'll attempt to match their selection against the case statements. If it matches, then it will execute the stub statement or method underneath that case statement. If it doesn't match, it will prompt the user with an invalid selection, try again. Next, unit test. So for unit test, our stranded island survivor needed to rest to regain energy. This method allows the player to enter the amount of hours to rest and the time of day. So to accomplish this, I created a calc energy rest gain method. Below, you see the matrix that was created to be able to test this method. Next, just like previously, I created a pseudocode using a Word document. And then later I translated that pseudocode into Java code. And as you can see on the right, there's if statements to capture invalid inputs. And if they're not invalid, it will execute the algorithm that was written in the pseudocode. Next, just like before, I created test cases to make sure that I was testing for valid and invalid results. After I created the test cases, I ran the test method, and on the right-hand side, you can see the results that we return after executing that method.
And again, we create another test matrix because our survivor needs to eat in order to maintain their energy level to perform daily tasks and stay alive on the island. This method you see here in the matrix it shows the player being allowed to enter the energy for a food item and the number of food that they want to consume for energy, and it calculates that out in the player's new energy level. Here we see the algorithm for it written out in pseudocode as well, just like before, with multiple if statements and an else statement that'll put out the new energy level. And then you see this on the right-hand side written out in actual Java code with the corresponding if and else statements. Then we implemented tests for this one as well, making all the corresponding variables and then duplicating that for additional tests. And you can see they all ran positive and worked as we're expecting.
Third example of this is testing the calc pack weight formula, and you see that the pack weight is several parameters on this. And the initial invalid column indicates that the pack weight needs to have some weight to it, otherwise it processes as an invalid amount. The far right column indicates the boundary at 40 pounds, so we set that as a parameter for the actor to not overload his pack. Survivor needs to have certain items in his pack to accomplish tasks, so it may mean that he may need to discard certain things and pick up other things to carry out whatever task is at hand. Next. Once again, pseudocode on the left, Java on the right, calculating the new pack weight for the items that are being discovered. Next. The test case for this also passed on all levels. Next.
And moving into the scope and lifespan of variables, we look at scope, which defines where a variable can be referenced and be used, and a lifespan dictates when a variable is active in memory and can be used. So we see here in the class health menu view that the variables established here, they will live and die within this class. They can be used by things that are also within the class, such as display health menu view and rest energy, but not any higher. And if we look over on the right-hand side, the method for rest energy also has its own variables for rest hours, time of day, and etc. And those variables will live and die within rest energy itself.
Pass by reference and pass by value. Pass by value means you're making a copy of memory of the actual parameter's value that is passed in, a copy of the contents of the actual parameter. Use this pass by value when you are only using the parameter for some computation and not changing it. Pass by reference is also called pass by address. A copy of the address of the actual parameter is stored. Use pass by reference when you are changing the parameters passed in. There's 8 primitive types in the pass by value, which we've used many of these in a class, as indicated here on the page. The actual values of the primitive types are passed and copied to the corresponding parameters in the function when it's called. Only a copy is accessed or modified and the original is left untouched. This is how values are passed in most cases. Pass by reference deals with objects. Objects are not passed by value, they are passed by reference, such as classes, arrays. The location of the object in memory is passed and copied. The example given in the lesson plan was of a person asking another for their phone number rather than asking for their actual phone. It points to the actual memory location. Here's an example.
Oops.
Or, here we go.
Maybe.
Nice. Good visual. And this is the end. Thanks for listening, Brother Anderson.